Hello, everyone. And so I am from Kinnovis. I'm CEO of at Kinnovis. With Kinnovis, we focus on visual analytics of graph data. And over the time, we have done many projects and solutions of how do we visualize and analyze information on the complex like a data set. And so in this talk, I really want to share some experience and thought over what's the best approach, or more like practical approach on gaining insights from complex data sets, and touch upon the life cycle of analytics. So from how you store the data, collect the data, store the data, to analyze the data, to visualize the data, and what's the some practical lessons I learned through all those years practice. So graph and visualization. And now I encountered the graph about 15 years ago, and as a physicist, I'm always looking for a optimal ways of to model the data, to represent the information. And a graph came to me as a way of a very practical way of connecting informations. And now we often see that graph is models how naturally how we think about things. Like we see things as connections. We see one thing we connect to the other. So here I want to show you a quick video that we produced almost like I see 8 years ago, and looking at how the collaboration happens in the enterprise space. And so the data, I'll let it play. Okay, I will stop here. The last few frames, you see the graph at the different industries, like from healthcare to the retail to yours to the banking industry. So what's interesting is you see some very distinctive characteristics. The characteristic that you can't easily describe, but you can see it, you can sense it. So here's a touch upon very important thing when we analyze information, when we look for intelligence from the data, is a lot of information is not so readily descriptable. Is we have to see it and before we can describe it, and hence it comes to a how the best for us to access those information. So there was some research early done like almost half a century ago. It's like there's a Miller's law is really states that our brain can hold about 7 plus minus 2 pieces of information. Another study shows that the chess masters are not play better by thinking more steps, but they play better by thinking better steps. So this is an interesting hint of how we work with the data, how we gain intelligence in the data. And now in this kind of a complex situation, for example, the graph I'm showing here with so many data points, humanly trying to understand it is almost impossible because like this is way more than 7. And now how do we chunk it and how do we abstract it become the key thing to gain the insight from the data? So here's another example. I just want to quickly show you. And so in this example, the data is high dimensional. It's how the people moving around in the conference space or event space, how they connect with each other. You have this movement, there's a time, there's what they visited, and by using the movement, using the color, and to chunk the information, it makes the information a lot more accessible. So I want to move on to the next slide. And now, this is a graph conference, and but we often take a graph for like a granted. That what is the graph? And from very beginning, the most common way of a graph is really we talk graph as communication. We graph as visualizing, showing the information. But however, and what is a graph database? And the graph database really is a data management system, how we store the information, model the information in a graph format. Well, in the middle, there is a step is how do we go from the data in the management layer to the data in the communication layer. So this is where today I want to talk about it. How do we go from the data in the graph data management to the communication? And we talk about data, we of course have to talk about a schema. Now, in the data management layer, the schema, when we store the data, we're concerned about how can we manage all this data, how can we capture all this data, how can we preserve as much truth as possible. And so the schema captured here, we used here is really optimized for ease of capture the data, ease of access the data. Now, when it comes to communication, if you directly bring the data you captured into the communication presentation, the chances are I see the galaxies, beautiful galaxies, but what does it mean? Is a question. So when we communicate, we need to be concise, and each element needs to have a lot of information. So this is a big jump, as you can see, when you go from the data storage to the communication. Now in the middle, you have the analysis step. Essentially, when you analyze the data, you evolve the schema from where it was in the data management to where it is in the communication. And here is where chunking and abstraction needs to be applied in every single steps. Like they have a very different, they are simple in the different ways. So the question really is how to keep it simple. Now let's talk about graph communication. So here's some example of graph visualizations, and you can see on the top left is where actually is a U.S. election 2020. I mined the data from the Twitter space and did some community detections to figure out the left and the right camp. And one of the things I was monitoring is to see if anybody shift from the left to the right or to the right to the left. And disappointingly, I didn't see any shifts. So that was a shocking discovery. And the other thing you can see, there's like a flight, and the bottom right is COVID mutation graph, and how COVID go from single place, the origin at the top, over the time spread out to the whole globe, and each node is a mutation point. So we use graph for communication because our brain is really good in parallel processing, and the graph represents some sort of nonverbal communication. Like you can sense the information without the need to describe it. and then you can describe it later. Once you know what you're looking for, then you can find a way to describe it. So this is how the creativity work. Creativity does not work from 1 to 2 to 3 to 4, like a step building. Creativity relies a lot of intuition. Is we need to see something, then we can use 1, 2, 3, 4 engineer step to build a path towards it. Graph also is really great for context. It presents all the contextual informations in one place, allow you to think them together. So here's a chunking at work. Now, let me quickly talk about the challenge for data measurement, data management. Now, when we store the data, and we need to store the data as simple as possible, and we need to make it as searchable, mass searchable, and that requires your schema to be simple. And but then another challenge is that the data needs to be as truthful as possible. And about an hour ago, during Paco's presentation, he had the quote from somewhere, which I couldn't remember the name. He says, the quote is, the data is imperfect map of underlying entity. So that's exactly what I see. So when we manage the data, we have to make trade-offs. In capturing the data, and so we want to capture as much truth as possible. So the simplest form of the data capture is the table, but the table also presents a challenge for keeping the truth. So I'll give you an example. So this is the US flight. First, just let me show you the video. So this is like, because I'm in San Francisco, so I show you in one day, all the flight in and out of San Francisco. So that's a data. This is a lot of data. And you can get this data from Department of Transportation, and they publish the data after 2 weeks. So let me go back to the data point. Now, the data they captured, they use a table to capture the data, but it has 120 columns. And so you're wondering why it takes 120 columns to capture this simple data set. It turned out, so this is like diversions occupies almost 40% of the columns. And what happens, each flight can be diverted. Now, diversion, you need to record a set of properties for diversion, but it can be diverted again. So in this table, they actually record up to 5 diversions. That's all because, and there's once in a million times you have one flight be diverted 5 times, then every flight needs to save the space to save this diversion. So a much more concise way of representing this information and capturing the truth, as you can see naturally, is the graph. This is Neo4j. Same data is stored in the Neo4j, and you use Neo4j schema to visualize. It's a much simpler, much more intuitive, much more direct, and allow you to capture truth. Because in the table, if the flight has 6 diversions, too bad, you cannot capture it. But here, you have the flexibility to capture it. Now, so the graph is great for capturing, to keep the schema simple and capturing a lot of unexpected situations. And how about JSON? JSON has a lot of flexibilities. Now, the JSON, in my opinion, requires a lot of management of business logic in the coding layers, in the application layers. So from the data management perspective, we want to detach the business logic from the data management. So if any, so JSON is really easy to store the data, but for an analysis, graph has a lot more advantage. Now, earlier we briefly mentioned about we have how we store the data in the data management in the graph database, and how we want to present the data for the communication. When you store the data in the data management, you need to have a very simple schema, but you have to have mass amount of data. So the schema needs to be flexible to capture all kind of informations. When you communicate, you need as few entity as possible. And one good example is when you store the data in the database, if you realize you have to put you put a property in the edge, very likely that edge should be an entity. And so for email is a good example. If you email person A to B, if you store the email in as edge, then you cannot forward, you cannot reject. And however, when you communicate, when you present, if you still keep in that raw format, you end up with so many pieces of information on the visualization that nobody can tell what's going on. So this definitely you need a translation layer. So here's where the analytics happens. So we developed a set of so-called graph calculus for exactly this purpose, to fill the gap in the middle. So I just quickly go over. There's a set of map is really like, if you're familiar with map reduce, is the map function. Aggregate essentially is a reduce function. Link is graph specific, is connecting to entities if match certain conditions. And then you have extract. Extract is like for the group of people, if they have something in common, you can pull that out as an entity of itself and establish a connection. So in this particular case, if you watch the Game of Thrones, you will see each person is a character in the Game of Thrones. The Lannister is a house, so all those people belongs to the same house. You could represent the people by grouping them together in the cluster, or you can pull the house out as a house entity and then connect them. So there's a this operator make it flexible in how you want to model the information. And then there's shortcut. Shortcut essentially is the inference step and merge is clean up. So here's the example of again taking the Game of Thrones and then you do an extraction, and you find all the houses which character belongs to, and then you can start aggregate query the information among all your neighbors, and now you get the number of character in each house, and you can simplify it. So this is like a step by step. I go back to the original data. So this is a bunch of nodes to establish the house, to do calculation and simplify just to the house. So this is like a analytic step to simplify from original information to a small number of entities that easy to digest. Now, this is really process. The whole process can be done with the code. And just take the extract as example. So this is a pseudocode for extraction. You loop over all the persons and you identify if the house belongs to the person, and then establish the node and edge. And a query is much better, especially cipher query, visually kind of map out what's happening. Is much easier to understand, much more direct. Now with the graph calculus, you essentially you have a single visual representation to perform the exact same functionalities. So this is make it really easy to, much easier to think, much easier to operate. So this is where, the simplicity is the key in every step. In data management layer, you need to keep things simple in schema so you can capture and manage a mass amount of information. In the presentation layer, you need to keep things simple so you can present things concisely and directly, clearly. Now, in the analytics steps, you also want to keep things simple so we can think more effectively in the higher level. So this is where the visual calculus, I think, is important to perform all those analytic steps. So I give you another example. So this is the example of a global money, some like drug money transaction data. So you can see all the dollar signs is one transactions, and person node is a person. And so if you bring them onto the map, you can see how the money goes from one continent to the other continent. But here, look at the bigger graph. You can gain some information. You can see, there are certain node, certain people has a lot of transactions out, certain node has a lot of transaction in. You can gain some information. Now, what if we simplify the graph? So the first we remove the transaction node, replace them with the edge, and make the size of the edge as a number of transactions or the amount of transaction. Now that makes the graph a lot easier to understand, to digest. And further, we can just detect community, we can start to see what's happening, and now we can apply a filter. We can figure out the most significant the pathways in the money transaction network, or you can also use path findings to detect the path that exists between entities. Now, or alternatively, you can, with this, we can just play through how the things happens over the time. And as you can see, there's now as you can see how the money flows, you might be able to see certain patterns. And then, like if you notice the one on the top left, you see a lot of things come in, then flow into the other places. So those kind of visual patterns is actually really hard to get just by looking at a static graph. And you kind of by making this kind of a time-lapse visualization, our brain can start seeing a lot of subtle patterns that's not easily accessible through just present the data as a table or present the data as a static graph. So that's what I'm talking about today. Is really like, if we think about it, the data from the data management layer, you have a very distinct requirement that data need to be simple, which is in the schema needs to be simple. And then in order to have an effective communication, the presentation needs to be simple. And now to go in between, you need to have a simple set of the tools to transform your data from where it was in the data management to the communication. Now, a practical implication is in the data capture layer, you want to be more explicit. Like I go back to the email example, you want to store each email as an email itself. So thus you can have person A send an email to person B, CC to person C, BCC to person D, person C CC the forward email to another person, or reply the email. So all those relationship is possible to be expressed. And if you make your the unit information like detailed, and now the challenge is if you directly represent that information in the visualization, it becomes very complex, very overwhelming. It's hard to think about it. So for communication, you need to simplify the system to communicate. Now in the middle, you could use coding, like using Python, using JavaScript to transform the data. You can also do that in the Cypher queries or other query languages to transform the data. But what I present here is a way of visually transform the data from the very detailed representation to a very concise representation. And because it's a visual, it helps you to think at a higher level. So one thing that's happening last year is everybody's talk about Gen AI with like Gartner 2024 really presented Gen AI and knowledge graph right in the center of the impact radar. And the consequence of it is what I see here is Gen AI is actually make the graph extremely relevant. So Gen AI makes it possible to pre-process the unstructured document into knowledge graph. By the way, the 80% of the data is unstructured, and the only 20% of the data is structured. Now, once you have the data in the knowledge graph format, and what I described earlier, the set of visual transformation can be applied for analysis. So with that, so this is my talk. Let's see if there's any questions.